Hello there. Today, we're going to be talking about rules of derivatives. Now, rules of derivatives are just like your operators: plus, minus, multiply, divide. These are what you use to find a derivative. These are what you use to calculate a derivative. And today, we're going to be going over the most fundamental rule, the power rule, and then we're going to be supplementing that with the chain rule. So, let's get into it. Starting with the power rule. The power rule says that the derivative of x to the power of n will always be n times x to the power of n minus 1. What I mean by that is if I were to take the derivative of x squared, I'd have x squared. I bring my 2 down here, so it becomes 2x, and then I subtract 1 from my power, so it's 2x times x to the power of 2 minus 1, which is just 2x. So that's power rule. Now let's do a couple questions with this. Try solving this one. The derivative of 3x squared plus x. Feel free to pause the video and try this out for yourself. But let's get into the solution. So whenever I have two terms, I can treat them as one individual term and the other individual term. So first what I can do is I can take the derivative of 3x squared. So 3x squared, I bring my 2 down here. So it becomes 2 times 3x to the power of 2 minus 1, which is equal to 6x to the 1. And then over here I can do the same thing with my x. So it's x to the power of 1. So I bring my 1 down. So it's 1x to the power of 1 minus 1, which is x to the power of 0. And the thing is, anything to the power of 0 will always be 1. So my final answer here would be 6x plus 1. Now let's try the same thing on the next question. This one's a little bit harder. We got 3 terms now, but it's the same thing. So pause the video and feel free to try it. Okay, so again, we take each individual term. So let's try x squared first. So we bring the 2 down. So it's 2x to the power of 2 minus 1, which is equal to 2x. Same thing here with this 2x term. So we get 2x to the power of 1. Bring it down. We get 1 times 2x to the power of 1 minus 1, which is equal to 2x to the power of 0, which is equal to 2. Since x to the power of 0 can also be written as 1. And now the final term, we got 4. It's 4. We can write this as 4x to the power of 0, right? And again, we bring this down here. So we get 0 times 4x to the negative 1. But the thing is, since we're multiplying by 0, this whole term will cancel out. So this will just give us 0. So our final answer then would be 2x plus 2. Right there. And then we got a couple more questions here. This one's just the same thing, but this time we got another new term. So this time we have an x cubed term. So let's try that. Let's do 5x cubed first. So we bring the 3 down. So it's 3 times 5 x to the power of 3 minus 1, which is equal to 15x squared. Then we got the 3x squared term, which is, we bring the 2 down here. So it's 2 times 3 x to the power of 2 minus 1. So that's 6x. And then we got 2x. So it's to the power of 1. Take the 1, bring it to the front. So it's 1 times 2x to the power of 1 minus 1, which is equal to x to the power of 0. So 2x to the 0, which is equal to 2. And then finally, we have the term 17. We can say x to the power of 0. And we bring 0 to the front. 0 times 17, x to the negative 1. And that's just 0. So one thing you notice is that whenever I have a constant term basically means that there is no x variable at that term. So this term will never change. Whenever I have a constant term, its derivative will always be equal to 0. And think about it this way. If anything is constant, it doesn't change, right? And since my derivative talks about the rate of change, and something's not changing, then the rate at which it changes is 0, right? It does not change. So that's the reason behind this 0. Now, all we got to do is just combine each of these terms and we'll get our final answer. So our final answer will be 15x squared plus 6x plus 2. That right there is our answer. Now, the last question we do before we get into chain rule is an indices question. And these questions are tricky at first, but once you realize the pattern, they're actually quite simple. So this specific type of question works with square roots and also fractions. So if I have a fraction, I can rewrite this as x to the power of -1, and then I can apply power rule onto it to get my derivative. And for root x, I can rewrite this as x to the power of 1/2, and I can then apply my power rule to find its derivative. So we have a square root here, which means we need to rewrite this as a power. So we can rewrite this as 1/2, and then we can apply power rule. So we take 1/2 to the front. So we get 1/2 x to the power of 1/2 minus 1. And then we can rewrite that as 1/2 x to the power of -1/2. And then this we can rewrite as 1/2 x, and then anything to the power of 1/2 is square root. And since it's a negative, we can put a negative power there. And anything with a negative power, as we just discussed, is a fraction. So we get 1/2 root x. And that right there is our final answer. Next up, we have chain rule. Now, chain rule is actually really simple, and it's one of my favorite derivative rules because you can see it really easily. And basically what it is, and it's, now we're going to move on to chain rule. Chain rule is actually one of my favorite rules because it's actually quite easy to spot. We use it when there's a function, so g of x, inside another function, f of x. So I've color coded this here. So we take the derivative of the outer function first, and then we take and then we multiply that by the derivative of the inner function. So before we try to solve that, before we try to solve that, I know it's a bit to take in, and before we try to solve that, I'm just going to show you a couple examples of what chain rule would be used for. So for example, we could use it on 2x plus 1 whole squared. So that's a function. The inner function is 2x plus 1, and the outer function is x squared. So what we've basically done is we've taken 2x plus 1, and we've plugged it in to x squared. So we make 2x plus 1 our input, like that. So it's a function inside a function. Another one could be sine of x plus 1. Yeah, sine of x plus 1. So it's always going to be something that's not... it's always going to be some sort of equation inside another function. So it's never just going to be x. It's going to be something like x plus 1, or maybe x squared plus 2, something like that, inside another function. So that could be sine of something, could be log of something, it could be e to the power of something. So this is usually what we're looking for. So let's try the first problem, and we'll do this together, and then you can try the next one on your own. So whenever we apply chain rule, we want to find what's the outer function and what's the inner function. So I've highlighted in red what the outer function is, so that's just squared. So we can say the outer function is x squared, and the inner function is 2x plus 1. So first what we need to do is we need to find the derivative of the outer function. So that's the derivative of x squared. So this is what we've just done with power rule. So what we do is we bring 2 forward. So it's 2x to the power of 2 minus 1, which is equal to 2x. And then one little thing is that we need to still have our original function plugged in. So we need to plug this back in. So we can then rewrite this as 2 times 2x plus 1. And then we have to find the derivative of the inner function. So, well, 1 becomes a constant, so we don't need to worry about that. And then we need to just apply power rule on 2x to the power of 1. So you bring 1 forward, so it's 2 times x to the power of 0, which gives us 2. And then all we have to do then is multiply the two together. So we get 2 times 2x plus 1 times 2. And that's it. That's our chain rule. And then what we can do is we can open this up. So we get 4, 2x plus 1. And then we can just distribute. So it's 8x plus 4. And that right there is our answer. Okay, now on to our last question for chain rule. We want to find the derivative of 1 over 3x plus 2 whole squared. So this looks quite tricky at first, but we're going to combine a couple of things from power rule and from chain rule here. So watch this. What we're going to do first is we're going to identify what's our outer function, what's our inner function, right? So our outer function here is 1 over something squared. But we can also rewrite that as something to the power of -2, right? So we can rewrite this as 3x plus 2 to the power of -2. Okay, that makes it a lot simpler, right? Because now we can just apply simple power rule. So, okay, well, we need to do outer first. So let's take the derivative of the outer function. So we bring 2 forward. So it's -2. And we'll label this as x for now. So it's -2, x to the power of -2 minus 1, which is -2 x to the power of -3. And one last thing, we can substitute in x over here. So we get -2 3x plus 2 to the power of -3. Okay, that's our outer function. And then we have to do our inner function. And we get the derivative of 3x plus 2. 2 is a constant, so that we don't need to worry about that. And then 3x to the power of 1, we bring 1 forward. So it's 3 times 1 times x times 1 minus 1. So that's just equal to 3. And then we can combine the two finally. So we get -2 times 3x plus 2 to the power of -3 times 3. So it's -6 to the power times 3x plus 2 to the power of -3. And anything to the power of a negative number is a fraction. So we can write this as -6 divided by 3x plus 2 cubed. And that right there is our final answer. I hope this has helped you in understanding chain rule and power rule. And in the next video, we'll be going over product rule and quotient rule. So see you in the next one. Bye-bye.